Hello, this is Kirt.
Marine Biologist.
Okay, so let me tell you a little bit about the research or the study that we're planning on doing this summer. So what I'm really interested in is how does ocean acidification affect octopuses? And let me tell you a little bit what ocean acidification is, because this is a problem that most people really haven't heard all that much about. One problem that we have is that as more CO2 builds up in the atmosphere, a lot of that is being absorbed into the oceans. And actually, to tell you the truth, all water all over the earth. Now the problem with this is that carbon dioxide reacts with water to make carbonic acid. And that lowers the pH or makes the water more acidic. So like I have this cup of water here, if I blow into it, that went everywhere. If I blow into that, the carbon dioxide from my breath dissolves into this water, and that water becomes more acidic as I just blow into it. And this is something that you can just measure with a basic pH probe you could buy off the shelf at a fish supply store or something like that. You could see the lowering of the pH just in something like a glass of water. And so this is also, though, going to affect all the animals that live in the water, especially live in the ocean. As the CO2 is building up in the water, it's getting more acidic. And we really don't know what that is going to do. Already, since the time before humans started putting CO2 in the atmosphere, we're already 30% more acidic than we were at that point. By the end of the century, by 2100, it's predicted that we're going to be over 2.5 times as acidic in the oceans as we are right now. We have absolutely no idea how this is going to affect the animals that live there. So what I'm interested in is trying to see how is that going to impact octopuses. So we are interested in taking octopuses, we're going to put them into aquaria, and we raise the carbon dioxide level of that to what we expect it to be at the end of the century, and try to find out how does this affect them. So we look at things like their physiology, their metabolic rate. Does it affect their metabolic rate? Does it affect their ability to breathe? And we also look at gene regulation. Do some of their genes get turned off or turned on or changed based on the raising of CO2 in the environment? This year, actually, we have a little bit interesting of an experiment that we're going to try to do. It actually turns out that the Puget Sound area already has high CO2. And that's kind of a long story about how that happens, but it makes for a really interesting experiment. So one of the challenges with ocean acidification research is that you can't just take an animal out of the wild, dump it into a tank that has high CO2, and expect it to react the same way that animals are going to react after they've spent their entire lifetime in high CO2, like what we'd expect to see as ocean acidification proceeds in the real world in the future. So to do a really good ocean acidification experiment, you really have to raise animals all the way from being laid as an egg or born, all the way through adulthood to see what's happening to them, because there's a really good chance that being born in high CO2, they'll have some sort of acclimation that you won't be able to see otherwise. Now that's really hard to do with octopuses. It's especially with the kind of octopuses that I work with. They have babies that swim around up in the water for 6 months or more, and it's really hard to actually raise them in the lab for that reason. Luckily, Mother Nature has provided us with a natural experiment. It turns out that the Puget Sound is already really high in CO2. It's as high as we expect the rest of the ocean to be on average at the end of this century, around 750 microatmospheres of CO2. So the octopuses living there in Puget Sound have already been raised their entire lives in this high CO2 environment. In fact, they've probably been raised for several generations in this high CO2. So this gives us an opportunity to already look at what octopuses living in this high CO2 environment could be like at the end of this upcoming century. So our experiment is going to be split into two parts. The first part is we're going to take octopuses from the Puget Sound that have been living in this high CO2 and put them down in lower CO2 to try to see if you put them in this lower CO2 over the course of a month to 2 months, do they lose their ability to tolerate or withstand the higher CO2? So we'll keep them in the lower CO2 for a month or two, and then we're going to take a bunch of measurements in them. How high is their metabolic rate if you put them in higher CO2? How easily do they breathe? How does gene regulation change at higher CO2? We'll check out if all of those, do they still withstand that just as well after a month of being at the lower CO2. Now, we will also take octopuses from Monterey Bay that has much lower CO2 than the Puget Sound. It's more similar to the ocean average. And we're going to take those octopuses and put them into the higher CO2 like you would find in Puget Sound or the ocean average at the end of the century, and keep them there for a month to 2 months and see, once you do that, do they get the ability, do they change or acquire the ability relatively quickly to withstand the higher CO2 within a few months? Or is that the kind of thing that needs to be built up over generations or over a lifetime? So that's really where our experiment is going to be. Now, that's not the only experiment that's going to be going on this summer. We also have Taylor Schrock, my second-year graduate student, is going to be doing her own research, and I'm going to let her tell you about that later on. Also, we're going to be continuing to look at the mystery octopus, or what we found out to be Moose Octopus Leoderma, the smooth skin octopus, deep water octopus that's strangely showing up in shallow water just north of Rosario Beach Marine Lab. And so we're going to be looking into what's going on with that octopus as well. So there's going to be plenty of stuff going on in the lab this summer. So yeah, stick around and come along with us and see how this goes.